is the evens, and then the odds are on Calc Chat. So 4-1 was that conversion from radian to degree to radian, decimal degree to, or degree minute second into decimal degree, and then coterminals, complements, all that stuff was in 4-1. Any questions on those? And the measure of the arc, that was all 4-1. A lot of little formulas, but yeah.
When it says like sketch the angle and center position, do you want to do like the whole like coordinate plane and then like the angle on it?
Yeah, like that.
Okay.
Is that what you mean?
Mm-hmm.
Yeah.
Okay.
So standard position just means start at the 0 and then circle whichever direction you need to go to get me to the end.
Do the arrow.
Yeah, because you're going to do it with your reference angle, so there's going to be 2 angles on one, so you'll need to show both. Yeah.
In these poems where like they give you in radians, like could you convert it to degrees if you want to?
Yep, you just got to convert it back to radians. So if the question gives you in degrees, you want to answer it in degrees. If it gives you in radians, you want to answer in radians. Yep. Okay, how about 4-2? So now this was moving like mostly through your unit circle or setting up your triangle and finding your trig functions. I would say 4-2 kind of gets combined with 4-4 because you start to move outside that first quadrant. But it's the same general concepts. 4-3 is your right triangle trig. So either setting up your triangle, or this is where you got using like finding the cosecant and the secant and that kind of stuff on your calculator. Again, make sure you check your mode there. If it's giving to you in degrees, make sure your calculator is in degrees. If it's in giving into radians, make sure it's in radians. You're going to have to bounce back and forth, so make sure you're comfortable and you're aware of it. All right, so 59 just says evaluate the trig function using its period as an aid. So I guarantee you're not going to see, I promise you, you're not going to see sine of pi over 6 because I'm not going to give you something that's on your unit circle. I'm giving you the unit circle, so you got to know how to apply it. So it would be something more like this. So if I did 17 over 6, I would get what? What's 17 divided by 6 in mixed number format? 2 and 5, 6, right? So the fact that it's an over 6, you should already know the coordinate point. I know the coordinate point is root 3 over 2 and 1/2 for sine would be 1/2. Now all I got to do is figure out if it's positive or negative. So as you move around your unit circle, -2 puts you back over here. And then 5 pi over 6 is past the halfway mark and into the in between a half and a whole pi, right? And then all students take calculus, tells you that tangent's positive, everything else would be negative, which means this is a -1/2. So use the denominators to get you your point, and then figure out what quadrant it's in, and that tells you the positive or negative sign. All right, so 62 and 61. These are your base on your even and your odd functions. So this goes back a ways, but if you remember, there are 2 functions that are called even functions, and those are cosine and secant. And what it means is that if I ask you for the cosine of a positive angle and the cosine of the same angle but negative, the actual positive negative sign on your function doesn't change. And if you think about why it happens, like think about what's happening on your positive and negative. So now that we know, like these are, like let's say this is positive pi over 6, right? And this is negative pi over 6. The coordinate point here is root 3 over 2 and 1/2. The coordinate point here is root 3 over 2 and -1/2. So if I were to ask you for the cosine, whether it's pi over 6 or negative pi over 6, that value doesn't change. But if I ask you for the sine, the positive negative sign changes, right? It goes from positive 1/2 to -1/2. And because that happens, tangent would also be affected. And it doesn't matter if you have it on the right or on the left, because if you did it over here, this would be 5 pi over 6, and this would be negative 5 pi over 6. This is negative root 3 over 2 and 1/2. And this is negative root 3 over 2 and 1/2. So this time the cosine would start negative, but it stays negative if I move to the negative angle. The sign doesn't change. So when you're looking at these, you basically are focusing here. If this is cosine, then it doesn't change the sign. If it's secant, because that's the reciprocal of cosine, it doesn't change the sign. But every other function is odd, and it would change the sign. Does that make sense?
So cosine and secant.
Cosine and secant, right? So, but if you look at 61, now it's sine, right?
Yeah.
So sine of t is positive, sine of negative t would be negative.
-3.
Yep, exactly. Okay, 4 was your trig functions of any angle. So this was moving around your unit circle. This is finding your reference angle. So Anna, before where I was saying like number 98 is what I'm talking about, where you'll have to graph your initial angle and you'll have to graph your reference angle in the same graph. So it would look something like that.
I don't get how it's negative 2 pi over 4, so it should, like, I drew the green, so it shouldn't be 7 pi over 4, is your reference angle?
Your reference angle will never be bigger than pi over 2. It's always less than 90 degrees. So when you draw your reference angle as negative 2 and 1/4 pi, that's the green one, it goes past your x-axis just pi over 4. That's the only difference from your x-axis. So when it's negative, it kind of doesn't follow the same rules as when we set it up. We wouldn't do like 2 pi minus it. You're trying to find the distance from that to 2 pi, or to 2 pi on that side. So if it was 2 and 1/4 pi, you either, whether it's positive or negative, you are 1/4 away from that 2. So it's pi over 4.
Never have like a negative reference.
Nope. It will always be between 0 and pi over 2, including, it could include pi over 2, but it's never going to be more than pi over 2 or less than 0.
How come the reference angle is up there? I thought you guys could do 360 minus.
Well, that's what she just said, but now we're negative, so the rules kind of change, right? Because you went in the other direction. So now 2 and 1/4 is bigger than 2, right? So you would do the reverse. You would do 2, you would subtract the 2 pi from the 2 and 1/4 because it's negative. You've gone past it. You're always finding the distance between that angle and the x-axis. So if that angle is here, then I'm literally looking for this distance, which is pi over 4. And it will always be positive for a reference angle.
Oh, it always has to be positive?
Yep. It has to be between 0 and positive pi over 2, including pi over 2.
It can't be bigger than pi over 2 or bigger than a half?
It cannot, well, a half pi.
Okay.
Yeah.
So that's why you take away the 2 and then you get negative pi over 4, but since it has to be positive.
Correct. Yep. And then we got into the graphing. So 4, 5 was on here for the sine and the cosine. Remember, you're going to get one of either the sine or the cosine, and then you're going to get the opposites reciprocal function. So if it's sine, you're going to get secant, so you have to do both. If it's cosine, you're going to get cosecant, so you're going to do both, and then you'll end up getting one of the cotangent or tangent. Okay, so 91 says, in the exercises, find the value of the 5 other trig functions of theta satisfying the given conditions. So it says secant is 6 over 5, and tangent's less than 0. So secant is the reciprocal of cosine, right? So this is the hypotenuse over adjacent. And you can draw yourself a triangle. Just realize that it doesn't necessarily make sense in direction. But this would be 6 and this would be 5. So I'd get 36 minus 25, and that's 11. This is square root 11. And then because the tangent's negative, that would tell you that I'm either moving back and up or forward and down, right? Because it's got to be negative. Because this is positive, this is always going to be positive, I know that 11 has to be negative. So really, if I was to put this in the right quadrant, it would be forward and down. So this would be 5, this would be negative square root 11, and this would be 6, and that would be my theta. But as long as you can apply it to where it needs to go, that's why they give you the tangent. If they're not giving you that information, then it means it's in the first quadrant, so everything's positive. But if you've got a sign change, then the only way tangent's negative while cosine's positive is if the y, or the opposite, is negative. And then from there I'd get negative root 11 over 5. Okay, so this says evaluate the sine, the cosine, and the tangent of the angle without the calculator. So 107 is negative 9 pi over 4. The first thing you should be able to figure out is that the reference angle is pi over 4. And from there, the coordinate point is root 2 over 2, root 2 over 2. Which means my sine is going to be root 2 over 2. My cosine, root 2 over 2. And my tangent is 1. Now all I got to do is figure out the positive and negative values of these. So if you do 9 over 4, this is negative 2 and 1/4 pi. So going negative, I would go this way. That's negative 2. And then 1/4 is less than a half, which means I'm in the fourth quadrant. All students take calculus. Tells you that the cosine's positive, but the sine and the tangent will be negative. which was 4, 5, and 4, 6. So there's 3 questions from those, and they count for double. So they're going to end up counting for 30 points of your test. You can get partial credit, but just be really careful. Don't make mistakes by graphing the wrong curve. Like, don't look at cosine and graph sine, or don't look at secant and graph cosecant. Be really, really careful. I will leave out the colored pencils so that if you're doing your reciprocal functions, or you have a vertical shift or something and you want to do that lightly in pencil and then go back over it in colored pencil, that's fine. As long as I could tell the difference between what you intend to be your overall answer and what you were shifting. And then 4, 7 was where we did the inverse trig functions. So obviously you're going to be restricted to what's on your unit circle. So that should at least narrow the bank for like questions like 168 to 170. When you get your unit circle, remember I recommended adding on this, like the sine and tangent is the first quadrant and the negative fourth quadrant. So I would add on those negative angles. Your cosine is the top part of your unit circle for the inverse functions. And then I would even add on your tangents. So what is tangent at 0? 0. What's tangent at pi over 6? Radical 3 over 3 because it takes 2 3's, right, to get 6. What's tangent at pi over 4? 1. What's tangent at pi over 3? Root 3. What's tangent at pi over 2? Undefined. And then you could just repeat. So even if you just wrote that, like in the corner on your unit circle, it's a good reference. That should make these questions go really fast and help with your time. And then something like 173, 174, 175 would be on the calculator portion. Okay, so 147 is cotangent, right? I'm going to identify that A is 1/2, which is going to be your amplitude. The B is 1, so the period is pi over B, which is pi. And then I'm going to take what's inside the parentheses, the x minus pi over 2, and set it equal to 0. And set it equal to pi, because this is cotangent. Add the pi over 2. X equals, this is gone, pi over 2. X equals, this is gone, 2 pi over 2 plus 2 pi over 2, which is 3 pi over 2. And then from the one on the left, you're going to subtract the period. And from the one on the right, you're going to add the period. So pi over 2 minus pi, 3 pi over 2 plus pi, 2 pi over 2, 2 pi over 2. This is x equals negative pi over 2, and x equals 5 pi over 2. So moving from left to right, that's the first asymptote, second, third, and this is the fourth one. So then you want to go to your graph. Negative pi over 2, positive pi over 2, 3 pi over 2, 5 pi over 2. Those are your asymptotes. And you got to find the points halfway in between. So halfway between negative pi over 2 and positive pi over 2 would be 0. Halfway between 1/2 and 1.5 would be 1 pi. Halfway between 1.5 pi and 2.5 pi is 2 pi. It's cotangent, so I'm going up on the left and down on the right, but I'm only going up to the half mark because that's what my A is. So a quarter of the way in, I'm at a half, and 3/4 of the way in, negative a half. And then repeat that for all 3 curves. 4 asymptotes and 3 curves is what you need for everything with an asymptote. So cotangent, tangent, secant, and cosecant. 144. So 144, the vertical shifts at the front. So that's still a vertical shift because it's separated by a plus, right? So A is still 2, as in this 2. B would be 1/3. So pi over 1/3 becomes 3 pi. That's your period, so that's here. So then I'm going to take the bx minus c, which is just x over 3, and set it equal to negative pi over 2. set it equal to positive pi over 2 because this is tangent. Multiply both sides by 3, and you get your middle two asymptotes are negative 3 pi over 2 and positive 3 pi over 2. And then from the one on the left, you're going to subtract the 3 pi. From the one on the right, you're going to add the 3 pi, and that's where these come into play. Negative 9 pi over 4 and over 2, and positive 9 pi over 2. And then plot those 4 points. Those are the ones that are in red or orange. Those are your asymptotes. And then my advice is find your zeros, which would be at 3 pi, or negative 3 pi, negative pi, positive pi, 3 pi, those, and then shift everything up to at the end. Because it's going to be easier to find, it's easier to identify your asymptotes from your key points and your zeros. But then you just got to, because it's got a positive shift, everything gets shifted up. Sine is here and here, right? If it's negative, it means it's here. And the root 2 over 2 is your over 4. So it would be negative pi over 4.
Because sine is no pi, right?
Correct. So this is sine, if you want to check this one. This is negative sine of x minus pi plus 1. The negative flips it upside down. The 2 makes it the amplitude. The b is 1, so the period's 2 pi. The initial key points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are your standard ones if your period is 2 pi. But then there's a phase shift of pi, so it's what's in the green. Added on all the pi's, and I got pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. Those I added onto my graph as the key points. And then your standard sine curve would start at 0, go up to 2, and back down. But this is negative, which means it started in the opposite direction. I've plotted a point here, 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 connected those points, and that's where I got the first one. But then it shifted up. And everything got shifted up one place, which means that's your final curve. Again, when you're giving it to me on the test, make sure I know the difference between which one is your answer and which one got you there, okay? Mm-hmm. This is the the cosine one, so amplitude is 2. The B is 2, which means the period is pi, the quarter, and the 3/4, and the half are there. This time there's no phase shift, but there's a vertical shift down. So I plotted those points. Drew my asymptote, drew the amplitude, that's the green, and then shifted everything down one place. Mm-hmm. This time you're graphing sine, so it's -2, which means it's upside down. 2 is your amplitude. Your period is 2, it should be 2 pi over 1/2. Flip that, and you end up getting 4 pi as your period, which means your quarter point is 3 pi, then 4 pi, that is pi, then 2 pi, then 3 pi. First one's 0, last one is 4 pi. This time there's a phase shift of 2 pi, so you would add 2 pi onto all of those. And your key points are 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi. And then those would be where your curve, so if it's sine, it would have started at the 2 pi, and it's negative, so it would have gone down, up, up, down, and then you want to continue that curve to the left. Everywhere there's an asymptote, everywhere there's an intersection, you want to put your asymptote, and then bounce your curves off the top and the bottom, so it should look like this. Mm-hmm.
And it's okay for you to just draw it like that.
Mm-hmm. God bless you. All right, this is the last one. The other ones are on the video, but I wanted to just go over this one because this, I think, is when it gets the trickiest when you're dealing with the reciprocal functions. So this is y equals 3 secant pi x over 2 minus 1. So that means you're graphing cosine. Your A is 3, which is your amplitude. Your B is pi over 2, so your period is 2 pi over 2, which becomes 4, and which means your key points are 1, 2, 3, first one being 0, last one being 4. There's no horizontal shift, so there's no phase shift, but there's a shift down this time. So what I did is just plot my key points, and then I plot my asymptote. So without the vertical shift, the cosine would start at the 3, work its way down, down, up, up, and it would look like this. And then what I would do is finish your curves on both sides for the cosine. Find your asymptotes before you shift your curve, because once you move this curve, you're no longer looking at the x-intercepts, right? They would be moved. So I would find my asymptotes first, and then the shift down one means I'm taking all of those points and I'm shifting them down one place. So this would be here, this would be here, this would be here, this would be down here, 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 and here. So now my curve, my cosine curve, looks like this, and then the parabolas are going to bounce off of those points. So it would be here, down here, and up here. So my recommendation is finding your asymptotes. If there's a vertical shift, find your asymptotes first, then shift it, then draw your parabolas. So the overall answer would be obviously your 4 asymptotes and then the 1, 2, 3 curves. This one's secant, so it would be cosine, 3 cosine pi x over 2 minus 1. The A is 3. Period would be 2 pi over 2, which becomes 4. Then the quarter points 1, 2, 3, and then first one's 0, last one's 4. There's no phase shift, so those are your key points. This time there's a vertical shift, so once you plot your points at 0, 1, pi, or 1, 2, 3, and 4, and then you draw your cosine curve, which would have been up 3, down, up, up, I would have then done my asymptote, so that's where these come from, and then shift everything down 1, that's where the white line comes from, and then from there, do your curves. So my advice with the vertical shift and the secant or cosecant is first graph, find your asymptotes, and then shift them up or down.